Okay, how about this first one? Why do they want to become ions?
They lose or gain electrons.
Um,
They become charged, either positive or negative.
so they have to become charged so they can gain or lose electrons. Can they gain or lose protons? No. No proton change, just that electron change. Why is it that they gain or lose those electrons?
Because they're not
L-E-E-L?
Ellie. Oh my god.
So Alfred Nobel's name is spelled wrong. All right. So they want to look like noble gas configurations, electron configurations. So why doesn't does the atom that has reacted no longer have the ability to react?
Because it's already in its noble gas configuration.
So the answer is no.
Yeah.
Okay.
The exception of noble gases.
I'd say no, definitely not. I'd say kinda. No without energy in. Yes. So if something is reacted, then it's just going to sit there stable. And it's possibly noble gas configuration. But if you put energy into the thing, then you can get it to react, basically go back to where it was before. So what's something that you do that with daily?
Your phone.
Your phone or your car, the battery in your car, the battery in your phone, batteries in general that are rechargeable. When you, during the course of the day, those metals are losing electrons. And if you didn't do anything to them, they would just stay like that. But I put energy back in so they backwards force the electron to be put back onto the atom. So they could react again, but it would need an energy input. Which
Why do batteries get like
worse?
like they don't hold as good of a charge over time?
It's a pretty drawn out discussion, but the basis is the process of forcing the electron back onto the metal doesn't work as well because the metal is connected to something that it just now will not let go of under those certain conditions. So you imagine that the amount of electricity that you want to pump into your cell phone battery isn't a lot of energy. Why do you not want to just shove tons of energy into it? It's a small confined space. The wall outlet at your house is only 120 volts. I mean, there's lots of reasons, but ultimately, I don't want to take a small consumer battery and shove a bunch of electrons into it forcibly. Because I mean, there have been instances where people have had like their thighs burned by their laptop batteries, stuff like that. So I mean, that's not charging per se, but regardless, it's electron flow. When you move electrons around, they get hot. The apparatus for moving the electrons gets hot, and if you try to move them really fast or really hard, they'll get really hot. And you can't have that. Say again?
It's like thermal runaway in an aircraft battery.
Like thermal runaway in an aircraft battery.
Out of the bottom of the plane.
In a way, that's a discharge thing though. It's not a charging thing, but it's sort of the same kind of concept going in the opposite direction. Regardless of which direction, charging or uncharging, that the electrons go, the movement of the electrons is warm. When you pick up your battery, not necessarily so much in the morning, but like while your battery is charging on your phone feels warmer because the electrons are going in. And if you have that happen too fast, what happens when things get hot? Expand. Do you want the battery in your phone to expand? It's sort of a trapped environment, right? I can't have that occur. Inside of a car battery, it's a little bit easier because there actually is space There's a fluid level, so you could have some expansion inside of there. The battery isn't filled all the way to the top with fluid. And the plastic that you use is sort of like a waffle, so if there is some expansion, it can expand, and then when it cools again, it can contract again, but you can't have that inside your phone. It'll just break. So you can take those batteries that don't really work very well anymore and send them someplace, and they can definitely move the metals off of the anion, but it's not something you really want to do like on your nightstand. Too much of a chance of fire. Which atom will be more likely to gain electrons in a chemical reaction? Silicon and bromine. Why? So what's the answer? And what's the reason?
Electrons in the same column as fluorine. and
So you
closer
could
to fluorine.
you could say higher. That's the reason.
And it needs one electron.
That's the reason it has higher electronegativity. The answer to this question is not it's closer to fluorine. Closer to fluorine is the answer to what question?
Which has higher electronegativity.
Sure, or how you know, right? But that's not actually the answer to this one is because it's got higher electronegativity. It's more likely to gain electrons because that's the nature of that element. Sulfite, how many polyatomic ions? Okay, so first, sorry, sulfate, not phosphate. Wait, oh yeah, SO3 minus 2. So I've got 16 protons for my sulfur, and I've got 8 protons times 3 for my oxygen. So 24, 52? Is it 50? Or 52? 24 is 40, and 50, it's 52. So why is it 52? So I've got these 16 protons are right here. All right, what was the question?
It's 40 and 42.
40 and 42? I'm not adding. 25. Oh yeah, it's 40 and 42. That's better. So that's 16, and then these 24 are from those oxygens, and then this 2 is that 2 right there. So you can, if you can add, you can get your number of protons, and in this case it's 40, and then when I'm looking at the charge, that's telling me that this has a -2 charge overall, and so those 40 protons have been canceled out, and then 2 more electrons have been thrown on top of that, so just 2 more than your total, so you get 42 electrons. Are you okay with that? So ion. How about that? That they do not equal. Molecule?
Pure substance.
Okay. So I have more than one atom, and together those atoms all have a proton electron number equal to each other, and it's pure substance. Cation? And a negative ion for the anion. Why would a lithium atom be happy to form a compound with a bromine? Yep. Wants to lose an electron, wants to gain one electron. What is the electron configuration before and after it reacts with bromine? Li, 1s2, 2s1, and then Li, positive charge, 1s2. And the bromine, it's going to be 1s2, 2s2, 2p6, 3s2, 3p, 6, 4s2, 3d10, 4p5. Probably should have just done the noble gas configuration. This is probably good practice though. So we'd have a positive next to the lithium, and we'd have a negative next to the bromine. Salt? Sure. A cation and an anion with a charge equal to 0. So give me some salts. I'll just put that one up there just so we don't have to talk about it, but give me some more.
Any of the things that were on our chart.
Okay, like?
Sulfite.
Nope, that is not a salt. That's a polyatomic ion.
Mercury sulfide?
That is not enough of an answer, but I'll take it today. You said sulfide? Okay.
Calcium carbonate.
Sure.
Magnesium acetate.
How's that not enough of an answer?
We'll talk about it today.
Epsom salt.
Okay. Why is Epsom salt a good salt?
Good for your muscles, good for your plants,
Good for your plants?
good for like, yeah, it's good for your lawn, it's good for different things in the garden.
I didn't know that. Definitely good for your muscles though. Sore or overworked, the magnesium will actually seep into the muscle tissue, and those ions allow for proper firing of the muscle cell.
Potassium sulfate,
Do we, anything in common with these things? They're metal with nonmetals. There is a time when that's not the case. We'll talk about it a little bit today, but I'll throw it up here now. Are there any metals there? But how do I know that's an ionic compound or a salt? And, okay, how do you know they're bonded ionically? Okay, how do you know that without me writing it down for you? No? What is this thing right here? No, just the NH4 I've got underlined. It's polyatomic ion. So then what kind of compound must this be? Ionic, which is a salt. Okay. Why are the salts stable? Already reacted. Long time ago. Awesome. I just love it when that happens. Okay.